class, we looked at how to solve basic inequalities. And we talked about how similar it is to solving an equation. So if I had this problem, 4x plus 1 is greater than 2x minus 7, it is exactly like if it had an equals sign. So I draw my line down the middle of the inequality, the greater than sign, and now I'm ready to solve. Just like if it's an equation, I pick an x side, I pick a number side. Now I get rid of my spies. I subtract 2x from both sides. And then I'm going to rewrite it because I know that good organized people who don't make silly mistakes rewrite the problem. So 2x plus 1 is greater than negative 7. Notice I didn't try to start subtracting my numbers without rewriting it. That's when we get confused. Now I can subtract my numbers. So this positive 1 is a spy. I subtract 1. And that gives me 2x equals negative 8. Be careful that negative 7 minus 1 equals negative 8 and not 6 or negative 6. My very last step is to get rid of my BFF. So I divide by 2 on both sides, and x equals negative 4. You'll notice I accidentally made a boo-boo right here. I put that 2x equals negative 8. But 2x does not equal negative 8. 2x is greater than negative 8. So now I get x is greater than negative 4. That's it. I'm done. Anything greater than negative 4 will make this equation work. Do we agree that 4 is greater than 2? 4 cupcakes, that is more than 2 cupcakes. I think we can all agree to that. What if I multiply, just for fun, both sides by negative 1? We know we can do anything we want to an equation or an inequality as long as we do it to both sides. So this is okay. So I multiply by negative 1 and I get negative 4 is greater than negative 2. What? That's not right. Negative 4 isn't greater than negative 2. This is not right. So, the same divide by negative 1. I get negative 4 is greater than negative 2, which that's not right. There is something about multiplying and dividing by a negative. It's the most absurd rule known to man that kind of makes sense sometimes. If you multiply or divide by a negative, you have to turn around the inequality sign. You have to flip the sign. So if I multiplied both sides by negative 1, I would get negative 4 and negative 2, but I have to turn this sign so it's facing the other direction. Now it's true. Same with division. If I divided one side by negative 1 and I divided the other side by negative 1, I would have to turn the sign around so it was facing the other direction. Let's look at this in context. If I have negative 2x is greater than 10, in order to get x by itself, I have to get rid of the BFF. That means I have to divide by negative 2. If I divide by negative 2 on one side, I have to divide by negative 2 on the other. Because I am dividing by a negative here, it means I have to flip my sign around. So x is less than negative 5, which makes sense. If I put negative 4 here, if I put negative 4 where there's an x, it would be 8. That's not big enough. If I put negative 5, it would be 10. Well, that's big enough. So x is less than negative 5. This is really sometimes very hard to remember. So, of course, when things are hard to remember, sometimes we like to sing. I have a song to the tune of When You're Happy and You Know It. When you multiply or divide by a negative, flip the sign, flip the sign. When you multiply or not divide by a negative, flip the sign, flip the sign. same is true with multiplying of a negative. If I want to get rid of this negative 5 in the denominator, I have to multiply by negative 5. If I multiply by negative 5 on one side, I have to multiply by a negative 5 on the other. And we just learned that when you multiply or divide by a negative, flip the sign. So I flip the sign. My answer is greater than negative 15. This is just one of those things you have to remember. If you multiply or divide by a negative number, so I multiply by negative 5 or I divide by negative 5, we have to flip the inequality sign. I know, it's ridiculous, but that's the way it is. See you all in class tomorrow.